Now, if we add an organometallic reagent to an ester or acid chloride, it's going to add twice because you have the leaving group. In the case of the ester, the OR group is the leaving group. In the case of the acid chloride, Cl is the leaving group. So let's go through the mechanism for one of these. Our reagent is phenylmagnesium bromide. Break that up and treat that as phenyl minus and magnesium bromide plus, which is a spectator, so I'm not even going to write it. So we start. Phenyl minus is a nucleophile. It will add to the carbonyl carbon. All right, now we're at our tetrahedral intermediate, but we have the OET group. That is a good leaving group. So what's going to happen next? Those electrons will come back down, and you'll lose OET minus. All right, so now we have a ketone, and the nucleophilic phenyl minus will add to the ketone. So here's our second addition of the nucleophile. Now we're stuck at the tetrahedral intermediate with the O minus. There's no leaving group. So now we can do the protonation step and add the acid. And here we have our alcohol product. In the second example, it's an almost identical substrate, except Cl is the leaving group instead of OET. Mechanistically, this reaction is going to be identical to the one above. The only difference is going to be you'll have a Cl here, a Cl here. On this step, the Cl will act as a leaving group to give you Cl minus. The product, or the major organic product, is identical. The byproduct is the Cl minus you lost, which it will actually get protonated to give you HCl. The same way, if we want to write it up here, OET minus, when you add acid to the reaction flask, it'll protonate any oxygens. So this one, it'll protonate the ethoxide to give you ethanol. In this example, we have a cyclic ester, and we're reacting it with a Grignard reagent, methyl magnesium bromide, which we're going to treat as CH3-. So what's a little bit different about this one is the fact that our leaving group, the oxygen, is tethered into the molecule, so it's going to be retained in the final product. So let's go through the mechanism to get to the product. The first step is what you already know. We add CH3- to the carbonyl. All right, from here, our leaving group is the oxygen, even though it's tethered to the rest of the molecule. I'm going to push these electrons down and break the carbon-oxygen bond. So we end up now with our double bond O, the methyl group's attached, and then we have the carbons that were part of the ring, and then this is bonded to what is now O-. All right, well, we have a ketone at the top, and that will react with a second equivalent of CH3 minus. Right, now we're at our tetrahedral intermediate, and we have our O minus from the oxygen that was part of the carbonyl. The second O minus is from the leaving group. So what will happen at this point is the reaction will be done. So you'll add acid, that's step 2, and the acid will provide a bunch of protons. I'm just going to draw 2 in for our electron pushing. This will protonate 1. Protonate the other. So then our final product, and you could draw this in more of a linear fashion if you want, but we end up with a dialcohol.